So today's note is about factoring polynomials. So we're getting into a very difficult unit now where we will be reducing and simplifying rational expressions. So in order to do that, you have to know how to factor. Okay, so there's many different types of factoring, and we did review it earlier in the course, but we're spending another note on this because it's so important that you know how to factor. So let's do a quick review. Factoring a polynomial means writing the polynomial as a product okay, so that means something times something, that's a product, and it is the opposite of expanding. Okay, so if you have this nice little trinomial here, if you go from something that looks like this into something that looks like this, that's called factoring. So here, this is an addition sentence being turned into a multiplication sentence, and the other way is called expanding. So here you go from something times something into something plus something minus something, okay? So we're going through the 5 major types of factoring that you should know, and then on the back of this note we're going into more types of factoring but with grouping, because that's the one that's takes a bit more work to think about what to do. So make sure you're solid on these first 5 types and then move on to the grouping. Okay, so always check for a common factor. A common factor is something that can be divided out of every term in the polynomial. So make sure you look for the highest number that can be common factored out and then the highest variable, okay? So in this case, 3x squared plus 6x, both of these terms are divisible by 3, okay? And both of these terms have at least one x. Okay, so what you're left with then, if you were to multiply this back, is x plus 2. Okay, because 3x squared divided by 3x is x, and 6x divided by 3x is 2. Another way to check if this is correct is in your head, just expand this back out and make sure you get back to the original. So 3x times x is 3x squared, and 3x times 2 is 6x. Okay, in this case, there's no number that we can factor out because 1, negative 1, and 2 do not have a common factor. But we can take out an x because all of these terms have at least one x. So we remove an x, then we're left with x squared minus x plus 2. Okay? Now, if you forget how to do this, just think about it once you have your decision of what to remove. So we've decided, actually, I'll just do these one at a time. We've decided to remove x. So to determine what's left, you just do x cubed divided by x, which is just x squared, okay? Then you do minus x squared divided by x, which is just x, negative x. And then 2x divided by x, which is 2. So that's how you get the 3 terms in a row, okay? Now you also have to make sure that it's fully factored. So in order to do that, there should be nothing left in the bracket that can be taken out of everything. So in this case, there's no number, again, that can be factored out, and there's no variable that can be factored out, so you know you did a full factoring. Okay, the next part is simple trinomial. So a simple trinomial is where your a value does equal 1. So that means basically there's no number right here. You just have x squared. That's how you know it's a simple trinomial. And of course, trinomial means 3 terms. So a square term, an x term, and a constant at the end. So then you just need to come up with 2 numbers that multiply to negative 4. Okay, and then the same 2 numbers that would add to 3. So 2 numbers add to 3. Okay, so another way of writing this is something times something equals negative 4, and something plus something equals 3. So I hope you can see that in this case it would be 4 and negative 1. okay? Now, -4 and +1 would multiply to -4, but -4 plus 1 would be -3. So you have to make sure that they both multiply and add to the appropriate numbers. So then once you've figured that out with a simple trinomial, you can go simply to x minus 4, x plus 3. So there's the -4 and the +3. Okay, to make sure you're right, just FOIL. X times x is x squared. 3 times x is 3x minus 4x. Uh-oh, I made a mistake. Okay, why did I put 3 there? That's not supposed to be 3. I just looked at this wrong. This is supposed to be -1. See how I caught my mistake? Okay, it's easy when you're doing factoring questions really quickly to make mistakes like that. Okay, and this should be +4, not -4. I was looking at this -4 and this 3 instead of these two numbers, okay? So notice that a quick FOIL can catch your mistake, okay? So x times x, so this is plus. X times x is x squared. X times, this is -x plus 4x, which gives you the 3x. And then 4 times -1 is -4. Phew, I fixed my mistake. I got it right. So remember, when dealing with simple trinomials, that's all it is. What two numbers multiply to the last number and what two numbers add to the middle number. You don't need to do any more work with decomposition. You can just go right to the answer. Okay, then we have our complex trinomial, which is where a does not equal 1. So in this case, the coefficient on the x squared is equal to any number other than 1. Now, a note of caution, make sure that you can't common factor it, because sometimes you can common factor it and then the new coefficient will be 1, in which case then you can just leave the factor out, okay, the common factor on the outside, and then just use simple trinomial factoring if your new a value is 1. But in this case, you'll notice there is no common factor, so you have to go to what's called decomposition. So decomposition means that you're trying to look for a sum, so two numbers that add to -7. So something plus something equals -7. Okay, that's the b value. But then your product is equal to a times c. So your a value times your c value. So you're looking for something times something that multiplies, in this case, to -120. Okay, so these numbers seem a bit large, and so you're starting to panic a little bit. So when you're in that situation, first start thinking of the products that multiply to -120. Don't start thinking about the sums. So you try and think about two numbers that multiply to -120, that when you add them together, get to -7. So think about what that means. That means that they're only 7 apart from each other. So for instance, you know that 1 times 120, if one of them is negative, will equal -120. But when you add those, that's 119 apart. So that doesn't make sense. So then you keep going down and down. So 2 and 60. So if one of those is negative, that would multiply to -120, 2 and 60. But adding them together, if one of them is negative, would either give you 58 or -58. So we need to keep going closer and closer together. What two numbers are closer together? So try dividing this by 4, try dividing it by 6. Just do some trial and error until you finally get to -15 and 8. Okay, -15 plus 8 is -7, and -15 times 8 is -120. So again, just keep trying to figure out things that multiply to -120 in order to find two factors that add to -7. Okay, that's how you do that. So now that you have your two numbers, you want to decompose the middle term. So 12x squared minus 7x minus 10, you want to turn this term into 12x squared. Okay, and so then you want one of them to be minus 15x and one to be 8x. Now I'm going to put 8x first, and I'll explain why in a minute. Okay, so you've decomposed the middle term. You haven't changed the value of this at all, because 8x minus 15x is still -7x. So it still equals the same thing, you've just put two terms here. So now what we can do, which is actually factoring by grouping. So you're looking at these two, and you're looking at these two, and you're finding a common factor in each grouping. So I put 8x first because 8 and 12 are more easily common factored, and negative 15 and negative 10 are more easily common factored. If I hadn't done this, I would have still gotten to the same answer. It just might have been a little bit more difficult. So I think, in my mind, I just think, well, 8 looks better with 12 and 15 looks better with 10. So now you have your two groups, and you common factor out each. So I can take out a 4x from this, and I'm left with x plus 2, okay? And then I can take out a negative 5 from this, and, oh sorry, this is 3x plus 2 over here. 3x plus 2, 4x times 3x is 12x, okay? And then I'm left with here 3x plus 2, okay? Notice it's not negative 2 because when I factor through, or when I expand through this negative 5, that will be negative. Okay, so if you did this properly, these two should be the exact same. If they are not the same, then the decomposition is not correct, or your common factoring is not correct. So go back and check your steps and find your error. So now I can take out the 3x plus 2 because they both share that. And then what's left is 4x minus 5. So there you go. That is the factored version of my original. Again, let's do a quick FOIL check. This times this is 12x squared, good. Then we have minus 15x plus 8x, that's minus 7x. 2 times negative 5 is negative 10. I'm good. Okay, so that is complex trinomials. I think it's the hardest one of the 5, so make sure you practice it as much as possible because you'll need to be quicker at it in this next unit because you don't want it to bog you down and take too long. So difference of squares. This is where you have something that's a squared, so some coefficient and x value, they're both squared. Okay, minus some number squared, okay? So this gives you ax plus b, ax minus b, okay? The reason why it's a plus and then a minus is because that gets rid of the middle term. So you'll notice here with my example, there's an x squared term and a constant term, but there's no x term. That's because, well, I'll tell you why in a minute. So you just take the square root of the number, so 4, the square root of the variable, so x, and then the square root of this number, so 3. Okay, so it's just square root everything. And then in the second one, you do the exact same thing, except that you put a subtraction sign. So 4x plus 3, 4x minus 3. Okay, so what this does, the plus and the minus, is when you're multiplying this through, 4x times 4x is 16x squared. 4x times 3 is negative 12x, and then 3 times 4x is positive 12x. So negative 12x plus 12x is 0x, so that's why there's no middle term there. And then 3 times minus 3 is negative 9. So that's why it has to be a plus and then a minus, is to get rid of that middle term, and also so that your last square is a negative. So it has to be a difference of squares, so it has to be a subtraction of 2 squares. Okay? Finally, a perfect square is one of the form ax squared, and then plus or minus, this could be a plus or a minus, 2abx plus b squared. Okay, and it is factored like this, ax plus or minus b all squared. Okay, so this plus, if this is a plus, then this should be a plus. If this is a minus, then this should be a minus. Okay, so if you want to color code that, you can. Okay, so you check for a perfect square, first of all by seeing this is something squared, and this is something squared. So this is x squared, this is 3 squared, and then this middle thing is 2 times whatever this is, x, and whatever this is, 3. So 6. Okay? So the middle term has to be 2 times this square root times this square root. So 2 times the first square root times the last square root. So 2 times x times 3 is 6, so that's how I know that that is in fact a perfect square. So you just factor this by taking the square of the first one, using the same symbol that's here, so in this case it's minus, and then taking the square of the last one, and then squaring the whole thing. That's it. That's it. Okay? So the square root of the first term, the same symbol that's in front of the x term, and the square root of the last term, all squared. Okay? So that's the same as writing, of course, x minus 3 times x minus 3, which you could have gotten to by thinking what two numbers multiply to 9 and add to negative 6, minus 3 and minus 3. So either way you can get to this, but if you identify a perfect square, especially if they're larger values, that can save you some time. Okay, so those are the 4 major types of factoring. If you need to, please pause the video and review them, because it's very important you understand these before we go on to grouping, which is on the next page.